Welcome to another video explaining the universe using the particle model. Today's video is on perpetual motion. Is it possible? That's the question. But what is it? Everybody expects it. Yeah, it runs forever. That's what you're talking about. Some machine that runs forever. But the definition from Wikipedia states that perpetual motion is the motion of bodies that continues forever. That's what everybody understands. A perpetual motion machine is a hypothetical machine that can do work infinitely without an energy source. That's one of the key points I'm going to be making about the energy source. This kind of machine is impossible, as it would violate the first and second law of thermodynamics. End of discussion. And yet people try again and again to make machines that are going to run forever. We don't often think about it running without energy. Just that we won't want to just keep it going. Well, there's lots of videos on the internet about different machines, but probably the most interesting one is not this particular video, but in this video, this gentleman, Praveen Mohan, is talking about the invention that Gaskara II did in the 12th century. He's an Indian inventor, and he builds this perpetual motion machine, and it's a wheel with ball bearings in here, and it's got tubes, and inside the tube is mercury. Each tube has an identical quantity of mercury, and mercury doesn't cling to the tube, and so it's a very clean shift of weights as the wheel spins. And as you watch the video, he gets to this point here, almost to the middle, where he spins it, and he spins it. It starts at about 8 seconds, but this is critical timing. He spins it, and then he watches and watches until it stops spinning, and then it just sits there and wobbles back and forth. And this is towards the end of it. It almost makes 2 minutes, but it stops. And there's lots of reasons why that happens. Well, there's other models that you may have seen. This is similar. It's a wheel where the weights are extended on us out here, and when you start this and you spin it, you got weights out here that are further apart, giving more torque on this side, and these weights are inside closer to the center, giving less torque. Yeah, well, does that work? Well, if you read about it, and any number of them will tell you that on this side you actually have fewer arms extended than you have on this side. You have more arms pulling here and fewer arms pulling here, and it tends to balance out, which is one of the reasons they say it really doesn't work. Here's another one, just a ramp. This is a magnet on top, and there's a ball here, a metallic ball that gets pulled up by the magnet. It drops through the hole, comes down and up here and goes through this opening. Maybe there's a flap there, I don't know, and then it goes up and down again. One of the pictures I saw showed the marble stuck to the metal ball. If you don't get it balanced quite right, it doesn't work. But what everybody uses, what's there in all of these, the Gaskara machine, this machine, they all use gravity. They're relying on gravity to push this down. And in the process of gravity pushing, it applies the torque. This one relies on gravity because the ball has to roll down and come over this way, but it also relies on G2 gravity. This is a magnet. And the magnetic field around this is controlled by, this is the part of the particle model. G2 gravity is what controls the flow of G1s around and through here. And it's the magnetic fields. It's the magnetic field that comes all the way down here that gives it the force to come up. Rely on gravity. You don't hear them say that. Almost, I don't think I read any of them said, oh, gravity is there. Is that an external source of energy? Do all three of these machines, Gascaras, this one and this one, they're not perpetual motion because they're using gravity? All these machines rely on gravity. So if gravity disappears, there's no perpetual motion. How does that work? It's not going to spin. Of course, if gravity disappears, well, that's you not only won't have perpetual motion. If gravity disappears, then we lose our atmosphere, we float away, and a lot more. And this is my conclusion. But wait, if gravity 1 is required for these machines to work, then it has an energy source. Maybe the definition of perpetual motion is wrong. Just an arbitrary definition, except most explanations talk about energy. That's where thermodynamics comes in. And you can't have more energy out than you put in, and that's where the violations come from. Well, let's forget about the gravity. Assuming the gravity's there, we have an external source. There are physical reasons why perpetual motion is not possible. Yeah, the fancy answer is thermodynamics. Forget thermodynamics. There's friction. You got to have those gears, ball bearings, smooth and almost frictionless. If it's going to run forever, problem is they wear out. It wears out and stops. You got to block the external interference. Isolate the system. What about magnetic fields that in the one case that uses a magnet, if you have a strong magnetic field, it's a problem. Wind, vibration, ground vibration, the vibration of the unit itself, because if it's not well built, it may, even though the bearings may be good, how well does it rotate? And of course, they're conceptually wrong. I already mentioned that. Most of them are failed in the first place. But there is one device I found that is quite interesting. That's called the Beverly clock. It's been running since 1864, not continuously. Yeah, it fails for some of those other reasons, but it's still working and it's still running. And there's a very interesting point about this one. This clock has yet to be wound. They never wound it up in the first place. It's self-starting. Quite interesting. This device, this clock, is at the University of Otago in Dunedin, New Zealand. Don't know that I'm saying that right. And here's the picture of the clock. And it uses energy. So it's not perpetual motion. However, continuing to move over a long period of time, that's not impossible. Because this device is a device which uses available energy, solar or water, for example, to do work for it. Not so much a perpetual motion device, just a very efficient machine. Okay, well, I'll show you some more pictures. Here's the inside of this thing. How clean it is, how well machined it is. It talks about dropping weights. I didn't see a video of this thing working, and even if you did, it would be too hard to explain just looking at it. But it's a well-built machine. Climate change. This Beverly clock A clock invented in 1864 by Arthur Beverley and located in the foyer of the Department of Physics at the University of Otago in Dunedin, New Zealand. It runs on atmospheric pressure and changes in the temperature. Atmospheric pressure and changes in the temperature. An airtight box inside a clock expands and contracts throughout the day, pushing on a diaphragm. Airtight box, keeping out the wind. This is just airtight. I don't know what he did about any magnetic shielding, whatever, but it's well built. It takes only a 6 degrees Celsius temperature variation over a day to raise a 1 pound weight an inch, and this in turn descends, powering the clock. Despite never having been wound, the clock has indeed stopped running a number of times due to mechanical failure, for cleaning, and on a few occasions when the temperature and atmospheric pressure remain steady for long periods of time. Despite this, because the mechanism continues to function, the Beverley clock is considered one of the world's longest running experiments. It's the closest everyone will ever see to a perpetual motion machine. It uses energy. And even gravity. It uses gravity because that thing drops because of gravity, the weight. Well, let's get back to gravity. Here's an interesting question. Is gravity a perpetual motion machine? The particle model assumes that the universe is infinite. An infinite universe, let's consider infinite space infinite in all directions, has an infinite number, almost infinite number of stars. Well, it would seem to be infinite, but I don't know how you can have an infinite number of stars in an infinite space and not somehow conceptually fill it up. So I tend to think of the stars being a different kind of infinity. In this infinite universe, we find out over the years of studying stars that they die and they are born. We've generally coined that phrase cosmological recycling. And what do I mean by cosmological recycling? Stars emit G1s and N1s and G2s and N2s and probably more. When the particles are gone, when that's in a sense, when the fuel is gone, the star dies. Now, here's something that you don't talk about, but this is possible with the particle model. These particles can combine in space. If the G1 has the right speed, right direction, and right distance to a N1 particle that's out there, it will orbit the N1. Thus, hydrogen can be manufactured in space. One of the something I read not long ago was that our universe, or whether it's a whole, I may not be saying this right, but 75% of our, I'm going to say it, of our universe is hydrogen. When you think of the particle model emitting all these things and the possibility of manufacturing hydrogen in space, you can see why hydrogen would be the most prevalent atom. These particles and atoms can be captured by a large object. The object can get bigger and bigger until a star is born. Now, okay, I'm not an expert in how stars die, how stars are born. So this is a simple analogy, explanation of the fact that this type of action actually helps me understand that, yeah, it's possible for stars to die, stars to be born. And as long as you're keeping in this infinite universe the same number or approximately the same number each day, nothing, the gravity field, the G1 particle field doesn't change. It's going to be there. Yeah, I can hear people with thermodynamics say, "Oh no, no, Bob, that's wrong." The second law of thermodynamics says all this energy is going to spread out smoothly and be evenly spaced all over, and sounds like the stars all disappear and gravity is gone. Sorry, at least for now. I'm not buying. As long as stars are born and stars die, you have the potential that gravity itself is a perpetual motion. And that concept's based on an infinite universe, the conservation of particles. Interesting point. Uh, these particles, ultimately, whatever state they're in, you can blow them apart and they can be recombined, but the particles themselves don't die, if you want to call it that. But the stars die and the stars born. Those are the objects we see. And I contend that all that sets up this idea for cosmological recycling. Perpetual motion. Based on the particle model, gravity appears to be nature's perpetual motion machine. A perpetual motion machine is a hypothetical machine that can do work infinitely without an energy source. Going around in circles here, it seems. Gravity has an energy source. The stars. Interesting point. And our own life experience tells us that gravity is there every day, every day. And yeah, I know our time span in the universe is so small, but even gravity has an energy source. By definition, it's not perpetual motion, but it sure seems to work continuously, day after day, year after year. My name is Bob D. Hilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention.